In activity 4, all kinds of equations, you are given 6 different equations and asked which of these equations represent proportional relationships. So we're going to fill in tables for each of these equations and figure out what the value of, what's the ratio of y to x, or y divided by x for each of those tables. We're going to use that idea to figure out whether or not there are proportional relationships. But you can also look at the form of the equation. Can you make these equations take the form y equals kx? If you can do that, then it represents a proportional relationship. So in this case, let's look at the ones where you cannot get them into this form first. And this one is y equals 4 plus x. Well, this is adding a value to x, not multiplying a value times x. So you cannot get this equation into this form. So this is not a proportional relationship. This one right here, y equals 4 to the x power. So whatever x is, you multiply 4 that many times together, that many times. So if x is 2, it'd be 4 times 4. X is 3, it's 4 times 4 times 4, and so on. Well, you cannot get this equation into this form. Y equals 4 divided by x. Well, that's 1 over x times 4. That's 4 divided by x. But this equation is y equals k times x, not k divided by x. So this equation you cannot get into this format. And the last one right here is y equals x to the 4th power. So 2 to the 4th power, 3 to the 4th power, 4 to the 4th power. And again, you cannot get this equation into this form. But these two you can. The easiest one is this one right here, y equals 4x. That's the same as this form, y equals kx, where k is just equal to 4. So 4 is the constant of proportionality. So x always gets multiplied by that same constant, giving you a proportional value for y. And in this one, x always gets multiplied by 1/4. So 1/4 is the constant of proportionality, giving you an answer of y is always proportional to the value of x. It's always 1/4 the value of x. And up here, y is always 4 times the value of x. All right, so let's fill in the table. The first one is 4 plus x. So I went through some of the calculations here. These are pretty straightforward. 4 plus 2, 4 plus 3, 4 plus 4, and so on. And then the ratio, y divided by x. And I also added 100 down here at the bottom, and you'll see why in just a moment. So 100 plus 4 is 104. And then these ratios. So 6 divided by 2 is 3. 7/3 is the same as 2 1/3. So you might go through why that is. 8/4 is 2. 9/5 is 1 4/5. And 104 100ths is 1 400ths. And notice, first of all, this is not a proportional relationship. And that's about how far the authors want you to take this. Just look at these values. They are different. They are not constant. They do not represent a proportional relationship. So no constant, not proportional. But notice further that the ratio of y over x, so the y value divided by the x value, decreases as x increases. So as this x gets bigger and bigger and bigger and bigger, up to 100, imagine it goes up to 1,000,000. So that ratio of y divided by x decreases, and it moves towards 1. And the question is why? So this is like the temperature example that we did before. So now you're adding 4 to a value that's increasing. It's getting bigger and bigger and bigger and bigger. Imagine this goes to 1,000,000. So 1,000,000, and you're going to add 4 to that. So it's 1,000,004 divided by 1,000,000. So this is why 1,000,004 divided by x equals 1,000,000. So that's essentially 1. You're adding 4 to that. You're not changing this value very much at all. So it's going to get closer and closer and closer to 1 as x gets larger and larger and larger, because you're adding 4 to that. It becomes meaningless. It becomes just very little. All right, the next one. y is equal to 4 times x. Well, 4 times 2, 4 times 3, 4 times 4, 4 times 5. And take these values for y, divide them by x, and you're going to get a constant amount, because y is equal to 4 times whatever the value of x that you insert in there or replace for x. So that means that y divided by x is equal to 4. So y is equal to 4 times whatever number you use. Now, if you look at this algebraically, 4x, which is y is equal to 4x divided by x. These x's cancel out, and you get an answer of 4 in the end. So this is a constant amount. It is 4 is the constant of proportionality, so this is a proportional relationship. 4 divided by x, 4 divided by 2, 4 divided by 3 is 4/3, 1 1/3, 4 divided by 4, 4/5, 4 divided by 5. So now if you divide by x, so 4/2 divided by 2. So 2 divided by 2 is 1. 4/3 divided by 3. So now take a look and think about what's going on here. So you're going to multiply. So you're going to use the inverse operation, multiplication, and you're going to multiply by the multiplicative inverse, which is 1/3. So this answer is 4/9. This is 4/4 divided by 4, or 4/4, which is 1, times 1/4, which is 1/4. 4/5 divided by 5. So here you're multiplying by the multiplicative inverse. So this is 4/25. So notice in this case what's happening. As x gets bigger and bigger and bigger and bigger, this fraction gets smaller and smaller and smaller, and it begins to approach 0. The point that you have to think about for this activity is just that this is not constant. So this is not a proportional relationship. There is no constant of proportionality, and actually the ratio of y divided by x actually decreases as the value for x increases, moves towards 0. Now x divided by 4, this is the same as 1/4 of x. So whatever value you plug in here for x, y is going to be 1/4 that amount. So that's going to be a constant amount. It's always going to be 1/4 whatever value you use for x. So y divided by x is equal to 1/4. So y is equal to 1/4 of x. So to show that, take the value for y, which is 2/4, and divide it by 2. That's the same as 2/4 times the multiplicative inverse, which is 1/2. So that's 2/8, which is the same as 1/4. You could have used 1/2 here. 1/2 divided by 2 also is 1/4. 3/4 multiplied by the multiplicative inverse gives you an answer of 1/4. These 3's cancel out. 4/4, oh, that's why I did this. These 4's cancel, these 3's cancel, these 2's cancel, these 5's cancel. So you always get an answer of 1/4. So the x value becomes the denominator in what you're multiplying by. So you're multiplying by the reciprocal of x. So that always cancels with the numerator of y. Does that make sense to you? All right, if you do this algebraically, it's x force times the multiplicative inverse. So x over 4 times the multiplicative inverse. So this x is always going to cancel with this x, and so you're always going to get an answer of 1/4. So the numerator of y is always going to cancel with x when you multiply these together, leaving 1/4 as the answer. The point behind all this is that it is a constant of proportionality, 1/4. So this is a proportional relationship. Y is equal to 4 to the x power. So if x is 2, it's 4 times 4. If x is 3, it's 4 times 4 times 4. Notice that's 4 times 16. If x is 4, this is going to be 4 times 64. So it's just one more 4 that you're using as a factor. If x is 5, it's going to be 4 times 256. So I went through a little bit of how to do these calculations. You might try to do these on your own. This is 4 times 16 is 40 plus 24. I actually didn't write that one out. But then 4 times 64, 4 times 60, plus 4 times 4 is 16. This one is 4 times 256, 4 times 200, 4 times 50, 4 times 6. Then over here, y divided by x. So take these values for y and divide them by the value for x. So you can factor out, you can do some factoring, factor out the 2 here. So this is 2 times 2 times 4. These 2's cancel, you get 8. 4 times 4 times 4 is 64. This one's a little bit tougher. You can break this up into 60 thirds, which is 20 plus 1 1/3. I'm not going to do this in too much detail. I'm just going to leave it here. You do have this as a PDF, so you can actually go to this figure, look at it, see how you do these calculations. 1,024 fifths. Well, 1,000 fifths is 200. You're left with 24 fifths. See if you can figure out how you get to 4 4 fifths for this part that's left over. 24 is the same. 24 fifths is the same as 4 4 fifths. And this ratio increases as x increases. So this gets larger and larger and larger. The whole point is that it's not constant. So there's no constant proportionality. It's not a proportional relationship. And the last one is x to the 4th power. So whatever the value of x is, you multiply that 4 times. So if x is 2, it's 2 times 2 times 2 times 2, 3 times 3 times 3 times 3. Notice that it's 2 of the factors squared. So this is 4 squared. This is 3 times 3 is 9 squared. This is 4 times 4 is 16 squared. And 25 squared. 25 times 25, 16 times 16, 9 times 9. And I left these down here for you to kind of think about how do you get 160 plus 60 plus 36 from 16 times 16. And how do you get 500 plus 125 from 25 times 25? So think about that. See if you can figure out how you get these numbers that get added together. And you divide by one of the factors. Well, that ends up just being x to the 3rd power. So this is, so you divide by one of the factors. So you're left with 2 to the 3rd power, 3 to the 3rd power, 4 to the 3rd power, and 5 to the 3rd power. So this answer is the ratio of y over x is increasing as x increases. So this is getting bigger and bigger and bigger. It's just that ratio is x to the 3rd power. And the point once again is that it's not constant. So there's no constant proportionality. It is not a proportional relationship.